Hi, this is Mr. Evans. Welcome to Room 310 Biology and a short video on water and its amazing properties. And sometimes I wonder why we even call the planet Earth. Earth is something solid that you can rest upon, but you think about the majority of the planet is covered in liquid. Makes you wonder why we didn't call the place Aqua, perhaps. But in any event, I'm going to make some English teachers very happy and throw a little bit of cross-curricular work at you. The Rime of the Ancient Mariner, and yes, I did spell rhyme the way the poet intended, is a ballad, a type of poem that was written in the late 1700s by Samuel Coleridge Taylor. And it concerns the ancient mariner, a sailor on a ship that got lost near Antarctica and was in a terrible storm and people were fearing for their lives. And an albatross, a large bird, appeared and it led the ship to calmer waters. Well, Ancient Mariner, for some reason, shot the bird with a crossbow and killed it. And a sort of a curse ensued, and the ship was left in very, very calm water, no wind. They couldn't go anywhere. They were running out of water. So imagine being on a ship surrounded by millions and millions of gallons of water you can't drink. It's hot, you're dying of thirst, and you come up with this great line, water, water everywhere, nor any drop to drink. It's from the Rime of the Ancient Mariner. But I'm here to talk more about the chemistry of water. Water is often referred to as the Mickey Mouse molecule because the hydrogen atoms will actually form this particular bond angle with the larger oxygen as part of the H2O. And if we look at this in a real chemical sense, what you are seeing are a hydrogen atom, another hydrogen atom, and an oxygen. They form covalent bonds, so they are sharing electrons to fill their outermost energy levels. But oxygen is extremely electronegative. It's greedy for electrons. It doesn't want to share equally. So as part of these covalent bonds, oxygen actually is pulling the shared electrons closer to it. That's going to leave the hydrogens with a very slight positive charge and the oxygen end with a very slight negative charge. A molecule such as this with oppositely charged ends we refer to as polar. And this polarity is what gives water its absolutely incredible properties. And if you follow along, these should make sense for you, but then you can ask questions in class about what you don't understand. So because of these oppositely charged ends, water molecules can link or bond with other water molecules. After all, opposite charges are attracted to one another. So if I look at this a little bit closer, I see this key idea of a hydrogen bond. It's represented with dotted lines right here. And notice it forms between an oxygen of one molecule and a hydrogen of another. They're the ones with the opposite charges. Remember, hydrogen bonds are very weak, but we're going to see them in a number of places in biology. And it'll be important for you to remember that hydrogen bonds can be easily broken. But this polarity and this hydrogen bonding is key to understanding water. So what are these really unique properties? My first one is cohesion. If I talked about a cohesive sports team, I'm thinking about a team that sticks together no matter what. Well, cohesion in terms of biology or in chemistry, water molecules stick. They are cohesive to each other. And once again, this is due to this hydrogen bonding. If you've ever noticed water droplets forming on the leaves after a rain, or you've waxed a car or truck and seen the water bead up after a rain, it's due to cohesion. The water molecules within the drops, they're attracted to one another and they are clinging to one another because of cohesion. Here's another word you've seen before, adhesion. It looks a lot like the word adhesive, glue, tape, sticky stuff. Well, this is a graduated cylinder, and I see a meniscus here you notice that the water climbs a little bit higher on the edges. Water molecules show adhesion. Water molecules cling or adhere to some other molecules. So water not only sticks to itself, it's attracted to or sticks to some other types of molecules. And I can remember it with this little cartoon here. Cohesion, water molecules stick to one another. Adhesion, water molecules will stick to some other types of molecules. And I can see this very clearly in the process of transpiration. Plants have a vascular system, sort of like your capillaries and veins and arteries. And water is absorbed by the roots. It travels upwards through very tiny tubes called xylem. And because of cohesion, the water molecules stick to one another in a column moving upwards. Because of adhesion, they cling to the interior of the xylem, and water will actually evaporate out from underside of leaves. So you get this continuous pull against gravity, as much as 100 meters for our tallest trees, due to those properties of water. Water is also the universal solvent. Now, a solvent is a material that will dissolve things. Water is called the universal solvent. It's a little bit of a misnomer. It's misnamed. Water dissolves many, many, many substances. Water is a great solvent. Water dissolves ionic compounds particularly well. Salt is ionic. It separates out into positive and negative ions when you drop it into water. And water will also dissolve polar molecules. It won't dissolve molecules that are nonpolar. So you may have seen oil spilled in a parking lot, and you may see it sitting on top of the water. You can't get oil to dissolve in water because of the differences in polarity. Water being polar, water will dissolve other polar molecules, but it will not dissolve nonpolar substances such as oil. Well, why do I have a picture of a blood vessel here? Blood is, a lot of it happens to be water. So many of the molecules that need to be transported through our circulatory system and go to other places, other cells, are dissolved in water. Chemical reactions take place primarily dissolved in water. It's a key part of your metabolism. Water also has an amazing heat capacity. Here's one of my favorite athletes, the tennis star Rafael Nadal, and he is sweating profusely during the course of a match. Why do we sweat? I know it's to maintain homeostasis, but how does that mechanism work? Why does this elephant spray itself with water when it's overheated? Well, the water is going to evaporate from either Rafael Nadal or from the elephant, and water has a great ability to hold heat. As the water evaporates, it's going to pull heat away from the organism that is overheated. And a great way to see this is to think about a pond. There are so many hydrogen bonds inside this pond holding all the water molecules together to cool it off, to actually freeze it. Think about it. Is water usually as cold as the air temperature is? Water holds heat pretty doggone well. And the air temperature might be, 15 degrees Celsius, but the water temperature is a few degrees warmer than that. You'd have to pull a lot of energy out of this body of water in order for it to freeze. So this helps maintain life throughout the wintertime. These aren't all of the properties of water, but there are a few of the important ones. So your big job now, you know what it is to read a little bit more and to come to class ready to ask some questions. Be curious.